So this is 4.1 number 51. We're trying to find the maximum height. And we learned a couple of things. First, we learned that relative max and mins only occur at critical points. And then if we have a continuous function on a closed interval, absolute max and mins occur at either critical points or endpoints. So those are a couple of things we learned. So we have a continuous function because that's a polynomial. Whoa. This is a, stop that. This is a polynomial, and we know polynomials are continuous. They're just these wavy things like that. And we have a closed interval, starts at 0, ends at 6, includes the endpoint. So this is a continuous function on a closed interval. The extreme value theorem says we have to have a max and we have to have a min. And they're asking for the maximum height. Okay, so we need to find the critical points to find the max and mins. So the first step we're going to do is we want to find the derivative of s, which is negative 32t plus 64. That's our derivative. And if we set that equal to 0, we find a critical point. Because again, I'm going to say this over and over. A critical point is a value of x where the derivative is 0 or does not exist. Well, we set that equal to 0. We subtract 64 from both sides, divide both sides by negative 32. 2 is our critical point. So that is a possible maximum or minimum point. Okay? Then we're going to find the actual height where it started, the height at the critical point, and the height at 6 seconds. We're going to plug all those in. I'll plug in 0. That's 64. Then you plug in 2. No, is it 64? I lied. 192. 192. Liar, liar, pants on fire. I looked at the wrong formula. Where's my eraser? Stop that. Okay, I didn't say 64. Okay, it's 192. Now you plug in 2. Dang, I better get a calculator because this is getting over my head. This problem's over my head because we threw the rock up into the air. You get it? Over my head. I think Madison wants to laugh, but she's embarrassed. Okay, plugging in 2. It's 4, negative 16 times 4, plus 64 times 2, plus 192. I'm getting 256. 256. And then I'm going to plug in 6. I'm going to plug in 6. Ooh, negative 16 times 6 squared. Plus 64 times 6 plus 192. I get 0. So here is the answer. When does a stone reach its maximum height? So read the question. 256 is the maximum height, but it says when. When is at 2 seconds. So the answer is 2 seconds. Now, let me make a connection for you from last chapter. Last chapter, we called this the velocity. And we reasoned when a stone is thrown in the air, it goes up, it stops, and then moves down. So when the velocity is 0, it's at the maximum height because that's when it stops. So last chapter, we set this equal to 0, and we said, well, since the rock goes up, stops, and then comes down, the time it equals 0, we know that's the max. So last chapter, that's how we did it. We set the derivative equal to 0, and we said, oh, that's the point where it's maximum because what goes up must come down, and that's the maximum height. This chapter, we're doing it differently. We're saying a continuous function on a closed interval, the max and mins occur at critical points or endpoints. So here's my critical point. Here are my endpoints. What is the height at each of those points? The biggest one's the maximum, the smallest one's the minimum. So now we're approaching it from more analytical, doing actual calculations instead of logicking through it, but just make the connection from the last chapter. Okay, that's number 51.